I was trying to help you, but then Jordan came. Yeah, I helped you so much yesterday.
All right. So let's just review the ideas here. So when you're drawing these, and I've got this down here, you're going to draw a long horizontal side. You're going to draw the angle that they've given you roughly to scale, and if it's acute, you've got some work to do. If it's obtuse, it's generally a little bit easier. Okay, so we draw this acute angle roughly to scale. We've got this side right here next to it, and then we figure out how tall this is, and we compare the size of this side over here with how tall that is, with that height right there. If it's not long enough, we're not going to be able to make a triangle. If it's exactly the right length, we're going to be able to make a right triangle, and that's pretty easy. Okay. If it's longer than H but not as big as B, okay, then we're going to be able to swing it out this way and make a triangle that has an acute angle right here, or swing it in this way and make it so it has an obtuse angle right here. And if this side over here is bigger than this side right here, the only way that we can swing it is out there, and we get just one triangle out of that. Okay? So we did an example on this one right here where we drew this long horizontal side. And again, the way to figure these out is this is angle beta, or angle B, capital B, I think this book uses sometimes. And this is side lowercase b. This one is across from that one. Okay? That means this one has to be next to it. So I've got this angle that I draw roughly to scale, that 38-degree angle. Then I draw that side 5.9 right here. And then I figure out what the height is. And we notice that on this particular one, notice that 6.4 is bigger than 5.9. That means the only way to make a triangle is to swing it out here. Hopefully that's relatively easy to compute those. Okay, any questions there? This one is a bit more difficult because if you take a look there, this is 41 degrees for alpha. This is side B and this is side A. This one is across from that angle right here, so this one has to be next to it. So here's our 41.2 degree angle. There's the side that's next to it, 10.6. We computed that that height had to be 6.98. That's definitely long enough. And in fact, it's long enough that we can swing it out this way and swing it in this way. And which way did I say you should swing it first? Out or in? Out, because that allows you to find this acute angle. And we pointed out, what is the problem with the law of sines when you use sine inverse to find an angle? What is the problem with that if you were trying to find an obtuse angle? Yeah, the range. The range for sine inverse is from -90 to 90. So the only part of the range that makes any sense is the part in quadrant 1. These are all acute. So you can't directly find an obtuse angle using the law of sines. So that's why we find this one right here. And you'll remember that I zoomed in on this and I said, look, if we figured out that this one here is 59 right here, that's also 59. So the way we could figure out how big that obtuse one is we do 180 minus 59.5, and then we go from there. Okay? Any questions? Okay. Let me finish up the notes, and then we'll take a look at a couple of problems from the assignment. Okay? So, in this textbook, if you read through the textbook, they actually make a distinction here. They say, what if this is obtuse? Okay. Well, then I want you to just take a look at this. If this is obtuse, then the one across from it has to be the largest side. Because if that's obtuse, it has to be the biggest angle. The one across, the side across from it has to be the biggest side. Is that the case here? It's not. So we don't get a triangle there at all. Okay. If this is obtuse and that one is the longest side, then we do get a triangle and we could set this up to solve. So I'm missing side, let's see, this is gamma, this is C, and this is A. So this would be alpha and this would be beta. And this would be side B. So I can solve for those missing sides. So I'm going to do this. Let's see, what do I need to find first here? I need to find an angle. I need to find alpha. So I'm going to set this up as the sine of alpha over 10 should equal the sine of 130 over 12. Now, do we have to worry about whether or not, gosh, am I going to get the right angle here? Is it going to be the angle that the calculator gives me, or is it going to be 180 minus that angle like we did on this one up here? Why don't we have to worry about the size of alpha? We already know it's acute, okay? If that one's obtuse, automatically these other two have to be acute, okay? So we do alpha would equal sine inverse of 10 times the sine of 130 over 12. And that would give us this angle right here, which is, what is alpha? 39 point what? 67. So that one right there is 39.67 degrees. Okay. And then you should be able to finish that off, right? If that's 130 and this is 39.67, I've used 169.67 degrees. How many degrees are left for this one up here? It's going to be pretty tiny, isn't it? Is it 10.33 degrees, okay? And then the only side left to find is that side B. And you can find that, right? Okay, are there any questions? Okay, sure? Okay, let's look at that example down at the bottom there. Okay, and did that copy pretty well on your paper? Can you see it all right? Really, really dark? Okay, so if you take a look up here, and I'm going to add a page so I can slide this up. There we go. So it says a bridge is to be built across a small lake from a gazebo to a dock. The bearing from the gazebo to the dock, the bearing from the gazebo to the dock is 21 south 41 degrees west, south 41 degrees west. So here's the diagram. There's south. It deviates 41 degrees to the west. From a tree 100 meters from the gazebo, so if you go 100 meters from the gazebo, okay, the bearings to the gazebo and the dock are south 74 degrees east. So you'll notice that this angle right here, that whole angle is 74. So from south we deviate 74 degrees to the east. That whole angle is 74. And then it says to the dock, it's south 28 degrees east. So here's south, deviate 28 degrees. So how big is, and I'll change colors for this, how big is this angle right here that's actually part of the triangle? What is it? 46. Okay, so it'd be 46. So if we were to draw a picture of what this looks like, it looks like this. That's 46 degrees. This is 100 meters. And then let's see. Be nice if I could figure out another angle here. Okay, if that's north-south and that's north-south, got 41 degrees right here, got east here. How many degrees are left for this little sliver right there? So let me blow this up so we can see it. How many degrees are left for this little sliver right here? 16 degrees. Okay, so that's 16 degrees. If this is a transversal right here, so if this cuts across that line right there, this would also be 16 degrees. Does anybody see how we're going to figure out what this whole angle is right here? So I can figure out what that angle is. That's a right angle, right? That's south, that's west. I've already used 41 degrees right here, so what's left for this little sliver in here out of those 90 degrees? 49 degrees. So if I take 16 and 49 and put those together, I end up with 65 degrees. And then I have angle, side, angle, angle, side, angle. Okay? So can I figure out what this angle is over here? Is it 69? Okay. And then you can figure out, now it says find the distance from the gazebo to the dock. That's what you want to find. You only want to find that one right there. Okay? Now, if you didn't follow that, let me just back up and make sure we're all clear on how to figure those out, because you've got to be able to figure those angles. And this is going to come up again because we're going to be doing some navigation problems with airplanes flying across country and being affected by wind and stuff like that. So you want to make sure you get this. Okay, this whole thing is 74. This is 28. So I subtract the two of those so that I get this angle right here in between these two sides. Whoops, I get that angle is 46 degrees. Okay, hopefully that one's not hard. The hard one to figure out is this one over here. So whenever you're given coordinates and directions and stuff like that, it's a good idea to draw a little set of crosshairs. So we've got northeast, southwest, northeast, southwest. Okay, and then you can figure out what's left. So if I've used 74 degrees right here, that leaves me 16 degrees. If I draw this side right here, remember from geometry, there's something called a transversal. Okay, this line right here that goes east-west is parallel to this line right here that goes east-west. So we call this a transversal. That red line there is called the transversal, and alternate interior angles are congruent. So this little sliver right here is 16 degrees. Okay? So I've got that 46 degree angle, and I've got 16 degrees, but I don't have this other little piece right here. So the way I figure that out is, if this is west and this is south, that's 90 degrees right here. I used 41 degrees there, so this is 49 degrees, and then I add those two together and I get 65 degrees. That's the key to figuring out this problem. Okay? All right, any questions? So we do x over the sine of 46 degrees is equal to 100 over the sine of 69 degrees, right? Okay, and what did you end up with? 77.05, and that would be in meters. Okay, so about 77 meters. Okay, any questions there? Okay, as silly as this seems, they do actually do problems like this. Okay, because there are times where you don't want to, can't or don't want to or whatever, stretch a tape measure across something like this. So you take a couple of measurements, make some calculations, and you've got a darn good estimate. Okay? All right, any questions? Okay. Any questions from the assignment? If you use the whole triangle, let's call this one alpha. You've got this side or angle corresponding to that side. You can figure out what this angle is right here, okay, using the law of sines. Okay, and then once you've got that, then you can figure out that angle up there. Does that work? Okay. Okay, so to make sure everybody's starting off right, what do you do first when you're given an angle, a side, and a side? Because that is the order they're given. Remember, this is angle A, this is side A, and this is side B. So this is the angle, this one's next to it, and this one's across from it. So we draw what? Okay, a long horizontal line. Draw the acute angle roughly to scale. So we're going to draw about 58 degrees. So we'll make that 58 degrees. Okay, and I'll even make this a little bit longer. Okay, what side goes right here? Okay, the 12.8. Okay, and then we figure out how long that has to be. Okay, what is h in this case? So h is going to be 12.8 times the sine of 58 degrees. 10.86. So it's definitely long enough. Okay. In fact, if we were to draw it roughly to scale, it would be about there. So we're going to swing it out here, and we're going to swing it in there. And the one that we're going to figure out first is the one that looks like this. So 58 degrees, 12.8, and then I label this one as 11.4. And if this is A, and this is side A, okay, and this is B, this would be angle B, and this would be C, and that would be side C. Okay, we figure out this one first. Again, why do we figure this one out first? Because it's acute. Okay, go ahead and do that. That's what you get, isn't it? And what does the calculator say that is? 72.2. Somebody want to confirm that? Okay, so this is 72.2 degrees. Okay, now once you have that, okay, there are a couple things that you'd want to do. I'm going to change colors here. This is the other triangle that we'd want to draw. This is 58. This is 12.8, and this is again 11.4. That's C, that's B, and that's B, remember? If this one is 72, if that's 72.2, this is 72.2, and we want to know what's the measurement of that angle, because then I can put it right here. And I figure that out by subtracting from 180. So I do 180 minus 72.2, and I end up with, so 107.8? Yeah. So 107.8. And once I have that, look at both of these examples. I have angle, side, a side over here, and an angle. I've got two angles. If I've got two angles, I'm nearly done. I find this one by subtraction, so I'd add the two of those together, subtract from 180, and what do I end up with? So that'd be what is that, 140, 130, 132? Yeah. 130.2, is that right? So this is 49.8, is that right? 49.8 degrees right here. And if I've got those two, I add those two together, subtract that from 180, and what do I end up with up here? 14.2. And then the only thing left to find on each one of these is side C, and that should be pretty easy, right? Okay. Any questions?